For the first case, the case is free undamped motion. The free undamped motion, it means the the undamped, that means the beta is 0. Free, that means no external force, so F at T equals 0. So this is the homogeneous with just the simple, like the second order plus the zero order term. So the M is the mass. And when we read the problem, make sure we use the weight as um, W equals M times G, or M equals the W over G. Okay. So the the unit, it could be in the metric system or English system. So we have to consider the system of the unit as well when you work on a problem or when you form the equation to get to the end of the process. All right. So the first case, free and damped, that means we just have the M, the x double prime plus k times x equals 0. This is the simplest version of the first model of this 5.1. Okay. And then to rearrange the term, make it cleaner into the, like the, based on the chapter 4, we recall as a standard form, right? The coefficient of the leading order is 1. So we divide all by m. So if we let km, which is with both of them are positive number, if km is omega squared, just for our convenience to solve the problem or to see the pattern of the solution. So we rewrite the k over m as omega squared, k as a spring constant, m is a mass, as we saw earlier. So then it becomes more like simpler version of the equation, like x double prime plus omega square x equals 0. For the free undamped motion is x double prime plus some constant, which is a positive numbers always, times x equals 0. And with the initial conditions, x at 0 equals x0 and x prime at 0 equals x1, okay, or the initial displacement and initial velocity. For the pattern, as you recall, the auxiliary equation, when you solve for the term like x double prime plus something like omega, um, okay, omega x equals 0. Since this one is always positive, the auxiliary equation is m squared plus omega squared equals 0. So then m gonna be plus minus omega I, right? It's always a complex solution when you have like this situation. So then the solution will be in the case number 3. Since the real part is 0, so the solution, which is supposed to be x at t, equals e to the 0 t multiplied by c1 cosine omega t plus c2 sine omega t. So since this term, the real part is 0, so the exponential part is gone. So then the general solution is just the simple form of the C1 times cosine omega t plus C2 times sine omega t. Recall the omega square is k over m. So then the omega is square root of k over m. So this number gonna tell us about uh, the the behavior or the pattern of the displacement at the point of time t, at any time t. Okay, after we get this general solution form, the period 2 pi over omega as the property of the trig function, the sine cosine, the period is from 2 pi divided by the coefficient of the variable t there, which in this case is omega. So t, or the period, is 2 pi over omega. And then the consequence of that, like the frequency, which is the reciprocal of the period, which is omega over 2 pi. Some problems, they have like sub problems to ask you after you get the general solution, after you get the particular solution using the initial displacement and initial velocity. There are more problems, more questions to ask you. What is the period? And then how long does it take to get there? Or what is the point of time that it comes back to the equilibrium position along that line? So then the period and the frequency will be part of the process to find the solution of those kind of problems. Okay, and we see the frequency, which is the circular frequency, which is the what is called the angular velocity. Okay, the omega is square root of k over m, which is from the adjustment of the term from the original form of the second order differential equation. Okay, and then sometimes the alternative form of the solution is more convenient to analyze the solution. So this is the another form of the solution that is equivalent to the C1 cosine omega t plus C2 sine omega t. The alternative form has just one single trig function in there as a sine function. The amplitude A is found by taking the square root of C1 squared plus C2 squared. C1 and C2, they are from the coefficient of the cosine and sine. And C1 and C2 will be found after using the two initial conditions. Then the omega, which is from square root of k over m. Okay? And the phi here, which is the phase angle, that for the graphing purpose, so you know where the first cycle starts with, okay? So the phase angle or the phi is from the inverse tangent of C1 over C2. That means the alternative form of the solution can be found. I mean, each parameters there, the A, well, omega is the same as omega of the original solution form, but the A and the phi, they are based on the C1 and C2. So the conditions, the the x at 0 and x prime at 0, those are the critical part that's going to give you the correct number C1 and C2.